we are given two integer arrays, lambs1 and lambs2, and they are sorted in non-decreasing order. Integer m representing the numbers of elements in lambs1, and integer n representing the numbers of elements in lambs2. So lambs2 has lengths of m, and n both equal to 3. Then we have to merge lambs1 and lambs2 into a single array and sort it in a long-decreasing order too. So the final sorted array should not return by a function, but instead it should be sorted inside the array lambs1. So to accommodate this, lambs1 has lengths of n plus n, while the first m element denotes these elements that should be merged, and the last n element, they are set to 0, they can be ignored. So element in lambs2 replace this 0 element. Look, these 3 elements coming from lambs1, and these 3 elements come from lambs2. So first, let's use a naive approach, just merge and sort. Intuitively, we just simply write the value from lambs2 into the end of lambs1, then sort lambs1 list in place. Remember that we don't need to return a value, as we should modify lambs1 in place. Let's try to implement them into code. Class solution, set a class solution, define merge function, self parameters, lambs1, and is an integer list, and m is an integer, and lambs2 is also an integer, and n is also an integer, and return none. Merge. First step is merge for I in range n. N is the last n element. We only loop last n element because they are 0. We need to replace this 0 into a get value. Replace this n0 element from element in lambs2. So lambs1 is get replaced I plus mf. M is how much it shift. Get the value from lambs2 at I, and then this is merge. After merge, we need to sort lambs1 dot sort. Yeah, so we already sort. Then we finished. We just get the input data here, and solution dot merge this 4 parameter, and print lambs1. Here we go. We already did that. Yeah, it is already merged and sorted. Let's talk about the space complexity. Most program languages have a built-in sorting algorithm that uses O of n space, and the time complexity, the cost of sorting a list of length x using a built-in sorting algorithm is O of x log x, because in this case we use sorting a list length m plus n. So we get the total time complexity is O of n plus m log n plus m. This approach has a high time complexity because we are not taking advantage of the existing sorting. Because each array is already sorted, we can achieve a O of n plus m time complexity with the help of pointer technique. By just use 3 pointers, they start from the beginning. So approach is first initialize the lambda1 copy to be a new array, and it containing the first m value of lambda1. And then we need initialize a read pointer p1 to read the values from the beginning of the lambda1 copy. So the space complexity is O of m because we allocating an additional array of lengths of m. Then we initialize read pointer p2 to read the values from the beginning of lambda2 and initialize write pointer p to write values from the beginning of lambda1. We performing n plus 2 times m reads and n plus 2 times m writes because the constants are ignored in the big O notation. So the time complexity is O of n plus m. The simple implementation is while p is still within lambda1, we compare the elements from the lambda1 copy and lambda2 and write the smaller one to the lambda1. If lambda1 copy at p1 exists and is less than or equal to lambda2 at p2, then lambda1 copy at p1 is smaller. So we just take it and write it into a lambda1 at p. Because we just used up of p1, then we need to move 1 to the right, means increment p1 by 1. Else, lambda1 copy at p1 is greater than lambda2 at p2. So lambda2 at p2 is smaller. So we just take it and write it into lambda1 at p. Because we just used up of p2, we need to increment p2 by 1. So after we comparing these if statements once, we need to increment p by 1. And so this right pointer also move on, and this will form a for loop inside a for loop. Let's implement them into a pattern class solution and define a function merge self parameter lambda1 is an integer list, m is an integer, and lambda2 is an integer list, and n is an integer. And return none. So first, inside the function, we initialize lambda1 copy. It copy the element from lambda1 from start to the m until mid m, and p1 initialize to 0, p2 initialize to 0. There are 2 pointers to read. And for loop, for p is the pointer in the lambda1 in range. This range is lambda1 range m plus m. If lambda1 copy at p1 is less or equal to lambda2 at p2, then lambda1 at p get the value from the lambda1 copy at the p1. And because we use the p1 pointer lambda1, so lambda1 copy, so we increment it, so they moved to the right. Else means it is bigger than the lambda2 at p2, so lambda1 at p get the value from lambda2 at p2. So we used p2 pointer, we just increment them, so make them to move to the right. And we also need to consider the boundary. So this is inside the boundary when the when the P1 is in the boundary, when the P1 is less than m, it less its boundary, and we can keep this. And also we need to consider when P2 is bigger or equal to n, when the P2 is equal to n means it's on the boundary, and greater than n means it's beyond the boundary. So when it's beyond or on the boundary, we just know we are run out of the P2. So we just to for loop over the lambda1 copy. So we finish the function. Let's try to get some input data, and solution dot merge, and we just use this and print lambda1 because we just set it to change it. Integer is not callable. Wait a minute. P2. Oh, we missed all. So we are done. It is changed. lambda1 is changed. Let's try to set 3 pointers start from the end. This is a medium level solution for such an easy level problem. Even for many LeetCode easy level problems, they will have many difficult solutions, but as a good candidate, you are expected to find them. The approach 2 already demonstrates the best possible time complexity. It's just O of n plus m, but still use additional space. This is because the elements of array lambda1 have to be stored somewhere, so that to make sure they are not overwritten. But what if instead we have overwritten the lambda1 from the end? Well, there is no information yet now, right? So this algorithm is similar to before, except the time we reverse the pointer backwards. We set P1 to point at the index n-1 of the lambda1, and P2 to point at the end of lambda2, index n-1, and P to point at the end of lambda1, index is n plus n-1. So P moves backward through the array. Each time we compare elements as P1 and P2, whose value is the bigger one will get the opportunity to write down the value. So the time complexity is still O of n plus m, is same as approach 2. But in this way, it guarantees that once we start overwriting the first m value in the lambda1, we will have already written each into a new position, right? In this way, we can eliminate the additional space. Unlike approach 2, we aren't use any extra array here, so the time complexity is reduced and become O of 1. So whenever you try to solve an array problem in place, always consider the possibility of iterating backwards instead of forwards through the array. It can completely change the problem and make it a lot easier. Let's try to implement them into a pattern. P1, initialize P1 is m minus 1, and P2 is m minus 1, and set a pointer P in the range plus m minus 1 to the 0, and decrement every time decrement 1. If lambs 1 at P1 larger than lambs 2 at P2, then the lambs 1 at P the value replaced by the lambs 1 at P1, because this one is bigger. We take the bigger one as a value, and P1, because we use P1, so P1's index decrement by 1, move from right to left. Else lambs 1 at P replaced by the else means the lambs 2 at P2 is bigger. Lambs 2 at P2 is bigger, so we get the bigger value, and P2 this time decrement 1. So, and we need to consider the boundary. The boundary is if P1 bigger or equal to 0. So make sure it inside. It shouldn't outside the boundary. It have to be inside the boundary. So if it is less than 0, that means we can just get a value from lambs at P2, and consider another boundary. P2 is must bigger or less than greater than or equal to 0. If it is smaller than 0, that means it also run out the for loop. So we need to break it up. So we are finished. It is giving me an and we are gonna to run this the list. We delete the list. So here we go. We did it. You might be a bit skeptical of this claim. Does it really work in every case? Is it safe to making a such bold claim? This way, it's guaranteed that once we start overwriting the first m value in lambs 1, we will already written each into a new position. In this way, we can eliminate the additional space. Great question. So why does this work? To prove it, we need to ensure that P, the point P, never overwrites a value in lambs 1, and P1 hasn't yet read from the lambs 1. Many software engineers are terrified of proofs, but good proofs are simply a series of logical assertions, each building on next. In this way, we can go from the obvious statement all the way to the one we want to prove. First, we know that upon initialization, P is n step ahead of the P1, right? In math word, P1 plus n is equal to P. We all know that during each of P iterations, the algorithm performs P is always decremented by 1, and either P1 or P2 is decremented by 1, 2. And we can also deduce that when P1 decremented, the gap between the P and P1 is stay the same, so there can't be overtaken in this case. We can also deduce that when P2 is decremented, so the gap between the P and P1 shrinks by 1 as a P moves, but not P1. And from that, we can deduce that the max number of the times that P2 can decrement it is n. In other words, the gap between the P and P1 can shrink by 1 at most n times. So in conclusion, it is impossible for an overtaken to occur, as they started n apart. And when P is equal to P1, the gap to have shrunk n time. This means that all of lambs2 have been merged in, and so there is nothing more to do.